Alright, today we're talking about section 5.1, angles of triangles. Have you talked about anything about angles of triangles before? You did some vocabulary? Okay. So today we're going to talk about how we can classify triangles. Okay? There's two ways to classify triangles. The first way is to classify by the sides. Okay? We can classify them by the sides. So there's three possibilities. It's either And what does isosceles mean? Well, we're talking about sides, remember? Sides. So two, what does that mean? Congruent, two congruent what? Sides. An isosceles triangle has two congruent sides. Got it? Okay, what's another possibility you think? Equilateral. What do you know about an equilateral triangle?
The sides are equal.
How many? Three. There's three congruent sides. So there's one more. Do you remember what it is? Scalene. What's true about a scalene triangle? How many sides are congruent? None. No sides are congruent. So why don't we have something on this list about one side being congruent? Yeah, that doesn't even make any sense, does it? Two sides are congruent, that means they have the same length, right? Three sides being the same length, one side having the same length as what? It doesn't make any sense, okay? So that's why we have no sides, two sides, and three sides. Got it? Any questions? So how else can we classify our triangles? We can classify them by their sides or their angles. So what kind of triangles do you know of?
Right triangles.
Right triangles. And what's true about right triangles? How many? One 90-degree angle. Why can't it have two 90-degree angles? It wouldn't be a triangle anymore, would it? Okay, good. What other kind of angles or triangles do you know? Obtuse.
More than 180 or 90, more than 90.
One angle, right? One angle more than 90. Oops, sorry about that. And just so we're specific about this, because we want to be right, we want to be good with our math vocabulary. One angle more than 90 what? Degrees, okay? We just want to be real accurate with our mathematical communication. That's important, okay? So somebody said another one? Acute. Oh, cute little triangle. What does it mean?
It said one angle less.
One angle less than 90?
Yes. Two. One angle less than 90 degrees?
It's not one.
Three.
All of them. All the angles are less than 90 degrees. All angles are less than 90 degrees. There's one more.
There's another triangle?
There's one more triangle. Yeah. One more type of triangle that we can classify by their angle. Equal what? How are we classifying it? Whoa.
They're all the same.
How are we classifying it? By their angles, so this is called an equiangular. Yeah.
That sounds so weird.
You sound weird. All angles are what?
Equal.
Well, if they're all going to be equal, how much are they all going to equal?
Nope.
How much do all the angles in a triangle add up to be?
180.
180? So it'll be 60, yeah, absolutely. Can I be picky?
60 degrees.
Oh, good, 60 degrees. Okay. Sorry about that line through the notes. I didn't mean to do that. It was an accident.
Yeah, I hate whenever I do that.
Okay, so far?
Yeah.
All right, so let's try an example. Okay, let's try an example. Example number 1. Let's see. Let's make that point A, and that point is at 0, 3. This is point B, and it's point 7, 1. And this is point C, and it's point 1, negative 1. Like that. So can we assume that this is a 90-degree angle based on my drawing? No. We don't ever assume by drawings, right? Because they could be inaccurate. I obviously didn't plot these points out here right now, right? I just kind of drew them a little bit. So how do you want to classify it first? Because I'm going to ask you to classify it both by its side and by its angle. So what do you want to do first? By sides or angle? Sides? Okay, so let's classify it by its sides first. What do we have to know about the sides? If we're classifying it by its sides, what do we have to know about the sides? We got to know the length of each side, right? So is there any sort of formula you know that can help you find the distance? Oh, the distance formula. Okay. All right. So what is the distance formula? Do you know it off the top of your head? Okay, here's what I want you to know. Okay? When you go to take the ACT, probably won't be next year because you're just freshmen this year, right? Yes. Or sophomores. Probably going to start taking ACT your junior and senior year. That is not a formula that they give you, but it's a formula they can test you over. They can ask you the distance and give you some points to figure it out. Okay, so it's good that you know it now. It's good that Mrs. Patton is having you learn it now because you need it later on. It's not just me making it up. I went to that ACT workshop last week, and that's what the guy said. And he took the test 18 times because he's trying to get a score better and better and better so he could get more and more money from colleges. Okay, so let's write it out. Distance formula. Square root of x2 minus x1, so the difference of the x's squared, plus y2 minus y1, so the difference of the y's squared, right? So what do you want to find first? Do you care? Let's do A. You want to find the distance of A? Oh, like A to B? Okay. So the distance from A to B, fix it please. Well, how do we know which one's which? Does it matter which one's x2 and x1 and y2 and y1? If I'm looking at this point right here, what do you want to make that? x2, y2 or x1, y1? X1, Y1. So I'm going to go and label that so we use it correctly. If this is X1, Y1, what's this? X2, Y2, right? Would it matter which one of these I chose to be X1, Y1? Like this one could be X1, Y1? And this one could be x2, y2? Yeah, absolutely, right? So let's fill out our distance formula. x2 minus x1. So x2 is 7 minus x1 is 0 squared plus y2 is 1 minus 3 squared. Well, let's simplify that a little bit. What's 7 minus 0? Oh, 7. Okay, 7 squared. What's 1 minus 3? Negative 2 squared. What is 7 squared? 49. And what's negative 2 squared? 4, right? Negative 2, something squared is it's just that times itself, right? Negative 2 times negative 2 is 4. What is 49 plus 4? So the square root of 53. So this distance right here is the square root of 53. You okay with that? Good. What do you want to find next? What are our two choices, by the way? What are our two choices? What can we find next? B to C or A to C? Does it matter? What'd you say? B to C, okay. Does it matter which one we find first? Yes or no? No, it does not, okay. So B to C, so if I'm doing B to C, do I want this one to be my x1, y1 and x2, y2? Oh, that's already labeled, so we just want to leave it there. So then let's make this one x1 and y1. Okay, so x2 is 7 minus x1 is 1 squared plus y2 is 1 minus y1. Oh, that's plus? How do you know that? Oh, so you know that because you're a genius. Okay, good. So let's simplify this a little bit. 7 minus 1, 6. So 6 squared, 1 plus 1. Wait, does anyone know what 1 plus 1 is? Okay. Scared me a little bit. Simplify it a little bit more. If we take it slow, it's not difficult, right? What's 6 squared? 36. What is 2 squared? And one last step. What is 36 plus 4? 40. Now that was the distance from B to C, right? So that was this distance right here. So this is the square root of 40. One more to find. Now we can't use what we had labeled before, can we? Because right now they're both labeled as x1, y1. So which one do you want to change? C? Okay. That's pretty easy though, right? Alright, so x2 is 1 minus x1 is 0 plus y2 is negative 1 minus y1 is 3. What's 1 minus 0? 1. What is negative 1 minus 3? Negative 4 squared. What is 1 squared? 1. What is negative 4 squared? 16. 1 plus 16? 17. So that means that was the distance from A to C. So this distance right here is the square root of 17. So your directions were, do you remember what your directions were? Classify it by its sides and its angles. What did we just figure out? By the sides, right? How will we classify this triangle right here if we're trying to classify it by its side? Why is it scalene? None of the sides are congruent. That's very good. Scalene. So now what do we have to do? Classify it by its angles. Okay? Now, what do most of these have in common? What do most of these classification? They all have something to do with 90, right? So if we can figure out the angle that we think kind of looks like 90, if we can say whether it is or not, that'll help to begin with, right? Because if it is, boom, it's a right triangle, done. If it's not, we have to think about it a little bit more. But also, can we tell right now that it's not equal angular? Even if I didn't draw these very well, we can still tell, but we don't want to assume, do we? Okay, so what do you want to do first? How in the world are we going to know if that is a right angle? What if I had this line and this line right here? How would I know if it's a right angle? If they were perpendicular? And how do you tell if two lines are perpendicular? You guys did this last week, right? How do you tell if they're perpendicular? Their slopes are opposite reciprocals, right? Parallel have the same slope, right? But perpendicular lines have what? Opposite reciprocal slopes, right? You remember that? Okay, so we need to figure out what the slopes of these two lines are right here, don't we? All right, so let's see if we can figure out the slope of this line right here. Look at the x value. What's the change in the x values right here? If we're trying to find from A to C, find our slope, what's the change? Sorry, I know it's x value here. Let me write this so I don't tell you the wrong thing. We know it's change in y over change in x, right? Does it matter which one of those I figure out first? Change in y or change in x? As long as I put the change in y in the numerator and the change in x in the denominator, correct? So which one do you want to do first? Change in x or change in y? Change in y, okay. So my y value right here is -1, and my y value right here is 3. So I got to find the difference of those two, right? The change. So what's 3 minus -1? I mean, if I wanted to start up here, right? I would go down 3, and then I'd have to go down 1 more to get there. So that would be 4. Okay? So if I'm starting up here, if I'm starting at A, I came down here. Now I want to go over. My x value is already at 0. How far do I have to go over to get to 1? 1. But what's true about this right here? If I'm looking from left to right, it is decreasing, isn't it? So what should be true about my slope? It's negative. So one of those values that we just figured out was supposed to be negative, wasn't it? So I went down 3 and over 1, so that should have been, I went down 3 and then had to go down 1 more because of that y value, so that should have probably been a -4 since I was going down, right? If I could have started right here, I would have had to go up 4 and then to the left 1. Either way, I would have gotten my slope as -4. Okay? So if this is a right angle, tell me what the slope of this line right here would have to be. Opposite of this, and it's reciprocal, so 1/4. Positive, right? Because it would have to be opposite sign. So let's see if we can figure out that line. So we already figured out that line right here. That was the AC. So let's figure out BC. Keep wanting to write them out of order. Sorry. So we know that slope is change in y's over change in x's. Our change in y's is what? One and -1. So 2. What's our change in our x's? If I do 1 minus -1, that gives me 2. So let's do 7 minus 1. 6. We know it's positive because it's going from left to right. It's increasing, right? So does that simplify to anything? 1 over 3. Are these two opposite reciprocals of each other? No. So is this a 90-degree angle? No. So we know that this triangle is not a right triangle, don't we? Okay. So we have, what, 3 more choices?
have 2.
Oh, why do we only have 2?
Because it's not going to be an equal.
So we know it's not going to be equal angular, don't we? Okay. So what about obtuse and acute? Which one is it? Why do you think it's acute? We know it's not 90 degrees, but how do you know it's less than 90 degrees?
Because it's not open like this.
It's not open wide, right? It's smaller right here, but it has something to do with these slopes.
Oh.
Okay? It has something to do with these slopes. I want you to talk about this with Mrs. Patton tomorrow to make sure that, because I don't want to tell you the wrong words. Honestly, I don't want to tell you the wrong words. Okay? I know it has something to do with these slopes right now, and she'll help you with it tomorrow when she gets back. Fair enough? Okay. So if we know that this angle right here is less than 90, then what do we know about these 2 angles right here? They're also less than 90, which makes this what other kind of acute? Any questions? So there's some other vocabulary words I need you to know. Okay? If you have a triangle, like that, whoops, and I'm talking about this angle right here, and I'm talking about this angle right here, and I'm talking about this angle right here, what kind of angles am I talking about of the triangle? Interior angles. What if I'm talking about this angle right here, and this angle right here, and this angle right here? What kind of angles are those? Uh-huh. Exterior angles. Another kind of exterior angle might look like this, and it might be us talking about that one right there. I know you're jealous of my drawings. Just try to do your best. There are some theorems that we need you to know. Okay? Do you guys know what a theorem is? Oh, you don't? What? Something has been proven? Or can be proven, right? Okay? Now these have all been proven, I promise. Okay? Not by me, but by other people way smarter than me. Yes, there are people smarter than me. It's okay. Triangle sum theorem. What do you think this theorem is going to have something to do with? Look at the name of it. What does it have to do with? Something about adding and something about a triangle, right? Okay? So here's the theorem. The sum of the sum of the measures of the interior angles of a triangle is do you know? The sum of the measures of the interior angles of a triangle? So like all these angles right here? What are they equal? 180. 180 what? Degrees. Good. I need to work on my vocabulary too, don't I? Okay. Wait, I thought you already told me that a second ago. So you already knew something that was an actual theorem? Good job. Let's talk about the exterior angle theorem. Because this first one dealt with the interior angles, right? Would it make sense that there's also an exterior angle theorem? Yes? Okay. I'm going to give you a drawing for this theorem to kind of help us understand and relate to some of the things we're going to talk about. I'm going to call this angle 1. I'm going to call this angle 2, angle 3, and angle 4. So tell me right now, based on the last theorem, what do you know about angles 2, 3, and 4? They equal 180, right? Because they're interior angles, they equal 180. That's right. Okay? But here's what the exterior angle theorem says. It says the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. So from that, we just talked about the fact that measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180, right? And what do we know about the measure of angle 2 and angle 3? This right here equals what? Measure of angle 1. So isn't the measure of angle 1 plus the measure of angle 4 also equal to 180? But guys, doesn't that make sense? Isn't this a straight line? So shouldn't angle 1 and angle 4 equal 180? Oh yeah. So let's try an example. Okay? Oh my gosh, I'm so sorry. I missed it on both ones, didn't I? 180 degrees. I apologize. So let's try an example. Try this. I'm going to draw a picture for you to help us out. This is 40 degrees also. This is 3x. And this is going to be angle 1. We're just going to call it angle 1. This right here is 5x minus 10. This measure right here is 5x minus 10. Does that make sense? My directions for you are find the measure of angle 1. Those are the directions. Do we have enough information to figure out the measure of angle 1? Well, let's start and see if we can figure it out. Okay? So what do you want to do first? What'd you say? What's the 5x minus 10 the same as? See, right up here, this was measure of angle 1, right? Well, that's the 5x minus 10. 5x minus 10 should equal what? These two angles right here. So in this case, excuse me, I said the wrong thing, 2 and 3. So it's these opposite angles over here, right? The opposite of the one that's like combined with angle 1. So 3x and 40 degrees. Now, do I need the 40 when I'm working the problem? Do you know that? I don't need the 40 when I'm working the problem. The degrees on the 40 when I'm working the problem. Okay. All right. Is this something we know how to solve? Yes. Oh yes. Right. I'm going to subtract 3x from both sides. When I do that, I get 2x minus 10 equals 40. What should I do now? Plus 10. Plus 10. 2x equals 50. Divide by 2. X equals 25. So that's my answer, right? I'm done.
False.
Why? Why not? The measure of angle 1 is not x? No, it's not. What do we know now? If I have x, what do I have enough information to find?
The angle of
I can find this angle and this angle, right? Which one will you think will help me the most?
the 5.
The 5x minus 10, right? Because that's directly connected to the 1, measure of angle 1. So 5, do I want to put x anymore?
Nope.
I know what x is, don't I?
Put
Oh, okay, parentheses and put 25. All right, I gotcha. Minus 10. And what should that equal? Well, what's 5 times 25? How much money do you have if you have 5 quarters? $1.25.
So awesome.
Minus 10. What's 125 minus 10?
Why'd you say shut up?
115. So what did I just find? That is 115 degrees, isn't it? Well, if I know the measure of this one, and I'm trying to find the measure of angle 1, what are those two supposed to add up to equal? Okay, so the measure of angle 1 should equal 180 minus 115. What is 180 minus 115? $65. So the measure of angle 1 is 65 degrees. Done. Wait, now am I done?
No.
Oh, I'm not done? What do I have to do still?
Yes.
My directions were find the measure of angle 1.
Oh, so we're done.
Oh, I am done. Okay, good. We gotta answer the whole question, right? When we get here, that's not enough. We have to go back, but if we get here and try to do something else, that's kind of too far, right? Well, it would be nice if we knew that this angle right up here was 75. Is it what they asked us to find? No. It's nice for us to know that. We can clap for each other if we know that, but we don't have to. Okay? For the record, if I just look at this triangle right here, and I know that that's 75, and I know that angle 1 is a 65, because we just found that measure of angle 1 is 65. What kind of triangle is this? If we're classifying it by its angles, what kind of triangle would it be? Acute, right? Because all the angles are less than 90. Good. Do you have any questions about that? No? All right, I got one more example for you. Find each angle measure. Okay, does anybody know what this one is? Oh, 90. Okay, yes, I got one of the three. I know that wasn't that hard, was it? Because it tells you it's 90 degrees. That's okay. So I really need to find the other two, right? What do I know about the other two angles of the triangle if this one equals 90? These two are like they add up to 90, don't they? Because all three angles have to add to be 180. I already used up 90 in this angle. So these two need to add to be 90. So let's say 2x plus x minus 6, that should equal 90, shouldn't it? Is that an equation we know how to solve? Okay, how do I solve it? Oh, combine our like terms? So I've got a 2x and an x. What does that give me? 3x. 3x minus 6 equals 90. Oh, add 6, okay. 3x equals 96. And then? Divide everything by 3.
32.
X equals what?
Oh, 32.
32. Done, right? I'm done.
Yep.
What are my directions?
Oh, find each.
Find each angle measure. So I found x, and that's great, but is any of the angles equal to x? No. So in order to get this angle measure, what do I have to do? 32 times 2. What is 32 times 2?
72.
Try again.
Oh.
64. How do I want to figure out this one? 32 minus 6. And what's that? 26. Now are we done? Find each angle measure. Okay, I knew this was 90. I figured out that was 64. I figured out this was 26. Yes, I'm done. Okay, you have any questions? Okay, so here's your homework. So I'll give you your homework in just a second. Okay, any questions about any of these examples, any of the theorems that we talked about, anything like that?
So is our homework going to be over this?
Yes.
Yeah.
Okay, any more questions?